To the principle of superposition. So recall, if we have the differential equation ay double prime plus by prime plus cy equaling some function f of x plus another function g of x, then what we can do is we can split this into two equations, solve their separate particular solutions, and then combine them. So if we have yp1 is a solution to ay double prime plus by prime plus cy equals f of x, and yp2 is a solution to ay double prime plus by prime plus cy equals g of x, then we can take our yp to be yp1 plus yp2. This is a solution to the original equation. So this is a solution to ay double prime plus by prime plus cy equals f of x plus g of x. So the reason this can be useful is if we have an equation like in this example, y double prime minus 3y prime minus 4y equals 3e to the 2x minus 5e to the negative x, where we have sort of two completely different types of terms in our forcing function on the right, we can split this into two method of undetermined coefficients problems, solve the two separately, and then put them together. So we're going to split this into two simpler problems. So we'll split this into two simpler problems. So we will have one problem where we are solving y double prime minus 3y prime minus 4y equals 3e to the 2x. And we will have a separate problem where we solve y double prime minus 3y prime minus 4y equals negative 5e to the negative x. So in both cases, we're looking at the same characteristic equation. So I'm just going to sort of go across the lines for the characteristic equation. We are looking at r squared minus 3r minus 4 equals 0, which factors as r minus 4 times r plus 1 equals 0. And we therefore get r equals 4 or r equals negative 1. So on the left-hand side, we have alpha equals 2 is not a root. And so we can take for our base guess simply yp equals a e to the 2x. On the right-hand side, alpha equals negative 1 is a root. It's not repeated. So for our base guess yp, we will need to multiply by x. And so we will use b times x e to the negative x as our base guess. On this left-hand side, we have yp prime is 2a e to the 2x, and the second derivative is 4a e to the 2x. On the right-hand side, yp prime would be, we would have a b e to the negative x, and then we would have minus bx e to the negative x. For our second derivative, we would have negative b e to the negative x from that first term. Then we would have another minus b e to the negative x from the second term, first part of the product rule. And we would also have a plus bx e to the negative x. So this becomes negative 2b e to the negative x plus a bx e to the negative x. From here, we can go about plugging in. So on the left-hand side, we will plug into y double prime minus 3y prime minus 4 equals 3e to the 2x. On the right-hand side, we will plug into y double prime minus 3y prime minus 4y, sorry about that, is equal to negative 5e to the negative x. So plugging in on the left-hand side, we are looking at 4a e to the 2x minus 3 times 2a e to the 2x minus 4 times a e to the 2x, hoping this is equal to 3e to the 2x. So we have got a 4a minus 6a minus 4a becomes a negative 6a e to the 2x equals 3e to the 2x. And this means that a must equal negative 1/2. So we get a particular solution on the left of negative 1/2 e to the 2x. On the right-hand side, if we plug in, we have a negative 2b e to the negative x plus bx e to the negative x. Then we have a minus 3 times b e to the negative x minus bx e to the negative x. Then we have a minus 4 times b e to the negative x. And all of this should equal negative 5e to the negative x. So our highest order terms should cancel out. Oh, sorry, this should be a minus 4 times bx e to the negative ex. My initial yp had the x inside of it. So with this, we have our x terms cancel out because we would have a b plus 3b minus 4b times x e to the negative x. That's good. So that cancels out. And then we also have a negative 2b minus 3b times e to the negative x. And this should all equal negative 5e to the negative x. So again, this first term just cancels out to 0. So we are left with negative 5b e to the negative x is equal to negative 5e to the negative x. And we can take b to be equal to 1. So we get on the right-hand side, our yp is just x e to the negative x. From here, we can go ahead and put this all together. So putting the two problems together. We can simply pick our yp to be negative 1/2 e to the 2x plus x e to the negative x. So again, it may or may not wind up being that much more work doing it all in one go if we just took our guess to be a e to the 2x plus bx e to the negative x. But this kind of allows us to not have too many terms all in one go. So if we have two completely separate types of terms, this is a trick we can use, and it's using the principle of superposition to do so.